Hello everyone, this is Siddiqur Rahman and welcome to the continuation of the fifth lecture of the second week. So let's begin. By the end of this lecture, you guys will be able to convert octal to binary number. Let's move into the next slide. This slide represents the overall scenario of this lecture. You may learn many things such as octal to binary conversion using indirect method, as well as you learn example of this method, and you can learn the table of the conversion octal to binary. Then you may learn the example of the direct method and so on. So let's move into the next slide. This slide represents the overview of the conversion octal to binary. So let's begin. There are various direct or indirect methods to convert a octal number into binary number. In an indirect method, you need to convert an octal number into other number system such as decimal or hexadecimal. Then you can convert it into binary number by converting each digit into binary number from hexadecimal system and using conversion system from decimal to binary number. So let's move into the next slide. This slide represents an example of the conversion, means octal to binary conversion, and this example using indirect method to solve this problem. So let's start with the question. In example 1, we see what is 205 base 8 in binary. We need to calculate the binary equivalent number of the given octal number. So in this method we are using two parts, and we in this slide the first part is given as follows. So let's start. First part and first step: convert the provided octal by octal number into the equivalent decimal number. So first we need to convert the provided octal number into the decimal number or into the equivalent decimal number. So let's start. 2058, as we already know that the base number of the octal number is 8. That's why we are setting 8 to the power 2, 8 to the power 1 and 8 to the power 0, and with multiplication of 205. Well, then we consider just 205, which is the equivalent octal, the equivalent binary number of the octal 2 is 010. The equivalent binary number of the octal 0 is 000, and the equivalent binary number of the octal 5 is 101. Well, then if you see the third line of the solution, then you can find there are nine numbers: 101, 000 and 010, and we are grouping 4 digits each one group. So our group formation is like as 1010, 0001 and 0, and the leftmost 0 we can ignore that 0 because just one digit in this group, that's why we cannot consider this digit. So the equivalent decimal number of 1000, which is 8, and the equivalent decimal number of 0101 is 5. So the equivalent decimal number is 85 of the given 205 octal number. So let's move into the next part of this problem. And here is the second part of this mathematical problem. So let's start. Second part and second step: convert the found decimal number or founded decimal number into the equivalent binary number. Since we have to convert octal to binary, so that's why we need to convert the founded decimal number into the equivalent binary number. So we can write, we found the equivalent decimal number is 85. That's why we write, or we have written 85 base 10, which is 0, 1, 00, 1, 000 and 01002. Well, we can we already ignored the leftmost one, because when we convert the decimal number into binary, we need to group 4 digits in each group. That's why the leftmost 0 is ignored. So then 10000 0101, and since the base number of the binary is 2, that's why we represents the third line of the solution in terms of 2 to the power something. Well, 1 into 2 to the power 7, 0 into 2 to the power 6, 0 into 2 to the power 5, 0 into 2 to the power 4, 0 into 2 to the power 3, 0 into 2 to the power 2, and 0 into 2 to the power 1, and 0 into 2 to the power 0. And the equivalent binary number is 1000101. Well, this is the equivalent binary number of the given octal number. So that's the answer of this problem. So let's move into the next slide. And this slide represents a table of the conversion of octal to binary number. As you see, if we choose a number from octal like 2, then the equivalent of this number, the equivalent binary number of 2 is 010. So let's move into the next slide. And from this slide, we may learn another method to solve this problem. And this method is called direct method. So let's begin with the question, and the question states that what is 540 octal number in binary. So we need to convert the octal number into binary. So let's start with the solution. Therefore, convert the provided octal number into the equivalent binary number. So we can write 540 base 8 is equals to, we already seen, or we have already seen the conversion table in previous slide, which represents octal to binary. So the equivalent binary number of the given octal number 5 is 010. Next, the equivalent binary number of octal 4 is 100, and the equivalent binary number of 0 is I repeat again, the equivalent binary number of the octal 0 is 000. So this is the equivalent binary number of the given octal number. I hope you understand both of the problem, what I meant, example 1 and example 2, which is represent using indirect method as well as direct method. I hope you understand very well the two methods. So let's move into the next slide. And this slide represents some of the examples for you guys to practice at your home by your own. So let's move into the next slide. Well, in the next lecture, you guys will learn another conversion named binary to hexadecimal. Next. So that's all for this lecture, and thank you guys for your attention, and see you guys in the next lecture. Thank you.